Hey guys, today we're going to go over a binary search question today. So not a LeetCode question. The question is called remove last duplicate entries. And it's a perfect question if you're just getting into hash maps and you're looking for a more advanced, easy problem using hash maps and arrays. Let's get into it. So this question is based off of a pretty simple concept. Pretty much what we have to do is we have to find all the duplicate numbers and delete their last occurrences. Let's take a look at this input array, for example, right? Take a look and see if you can see the duplicates. So let's take a look here. We have a duplicate 1, because 1 shows up here, and we have a duplicate 3, as 3 shows up here and here, right? And so deleting the last duplicates pretty much means looping through the array, going from left to right. We're going to pretty much delete the last element we see of a certain value. So the ones we are going to delete are this one, and this 3, since those are duplicates and the last time we see 1 and 3. We don't delete the 4 or the 5 because only one of them exists in the array, so therefore they're not a duplicate. So let's see what our output would look like. So after deleting the 3 and the 1 from the end of our array, we're going to get the output 1, 3, 4, 5. This is the example you'll also see on the binary search website. So let's think about how we can actually tackle this problem. One of the first things we need to do in order to solve this problem is figure out how to find if a number is a duplicate. One way we can do that is make a simple hash map counter. If we make a hash map counter that goes through the array, we know that if we've seen a 1, for example, at least 2 times, any number at least 2 times, that is a duplicate number. You'll see in our input example, the 4 and the 5, they're only seen once, so they're not duplicates. The 1 is seen twice, and the 3 is seen twice. If the 1 is seen 100 times, for example, it would still be a duplicate. So let's go through and see what our hash map would look like. So we're going to initialize our map to an empty hash map, right? We're going to see our 1. It's not in our hash map, so we're going to initialize its value to 1. Now we're going to move our pointer forward, going to the 3. We haven't seen a 3 before, so we're going to initialize it to 1. Now we're going to move forward, go to our 4. We've never seen a 4 before, so we're going to initialize it to 1. Now move forward, we're going to see the 1. So now we're going to add 1 to where we have seen our 1 before, giving us a value of 2, right? Same thing is going to happen to the next 3. We're seeing a 3 for the second time, so we're going to see plus 1. It's going to give us a value of 2 as well, right? And we're going to see 5. We haven't seen a 5 before, so now we're just going to set it equal to 1. Alright, so with this hash map, we're able to see which numbers are duplicates. So now we have to get to the other part of the problem, removing the duplicates. A super important pattern when you're removing from an array is this. If we remove, let's say the 1 in this example, if we remove this 1, all of our other values are going to shift to the left by 1. You'll see the 1 index becomes 0, the 2 index becomes 1, and it's going to keep on moving forward like that, right? And so it's important to recognize that. If we take a value off from the left, everything to the right of it's going to shift to the left. So that should bring us to the conclusion that we should remove items from starting at the end, move towards the front. Because look at this, for example, right? If we delete the 5 here, say we delete the 5, right? It's not a duplicate in this example, but we deleted it. None of our other indexes have changed, so we're not going to run into any strange index errors, right? Let's think about how we can approach our solution, creating a pointer that starts at the very end and goes to the very front of our array. Let's think about a condition that means that we need to delete this duplicate, right? So let's think about this. 5 is in our hash map, right? But it's not a duplicate because its value is 1, right? So let's move forward now. We don't have to deal with that as a duplicate. 3 is different though. 3 is in our hash map and it has a value of at least 2. This means we should delete 3. And you'll see, to get around the fact of messing with the other 3, we can actually take the 3 out of our hash map. So imagine that condition check we made, right? If 3 is in the hash map and its value is greater than 2, right? If our pointer moves to the other 3, it's not going to meet the condition of 3 being in the hash map. That way we only delete the values we see at the very last entry, right? So let's take a look at 1 now, right? The same thing's going to happen to 1. We're going to say, okay, we are at 1, it's still in our hash map, and its value is greater than or equal to 2, right? So what we can do is delete the 1 from our hash map and also delete the 1 from our array, right? And you'll see this gives us the same array we had previously going through the example, right? And so this is kind of an intuitive way to solve the problem, pretty much looping through and then looping back. There are other ways to solve this problem, but I feel like this is one of the best ways for a simple solution that's easy to understand. Let's code this out. Alright guys, let's get into solving this problem. So, first things first is some more simple syntax. So pretty much we're going to initialize our hash map, which we can call map here. And we're pretty much going to go for every single number in nums and create a basic hash map counter. So for number in nums, so if the number is in the map, we know it already has a value, so we can say map of number plus equals 1. Else, we have to initialize a value for the map of number to be equal to 1, because that's the first time we're seeing that number in the hash map. So that's our basic counter, so we have that initial information to deal with, right? Now we have to make a loop that starts at the end of our array and moves forward, right? So how we do that is we set a index pointer to the length of nums minus 1. That's an easy way to get the last index in your array. And so we're going to say while I is greater than or equal to 0, because we want the code to run at index 0 is a way to think about that, right? So we can process that last index, right? Now let's think about why we deleted the 1 and the 3 in our example, right? We deleted the 3 because of 2 conditions, right? It was in our hash map, right? So let's just say current is equal to nums of I. So we have that current value, right? So if current is in our map, right? That's what we talked about before. It's in our hash map, and that value is greater than or equal to 2. And this pretty much is saying that we still have to delete it, and its value shows that it's a duplicate, right? If this is the case, we can go in and we're about to delete the index, or we're going to delete the value from the array, right? So we need to save it. So we're going to say save is equal to nums of I, right? And you're going to see why, because right now we're going to say delete nums of I, right? This deletes it from our array. It deletes that index from our array. And so we're also going to delete it from our hash map as well. So hash of save is also deleted. This does both of these steps we talked about in our diagram. It deletes it from the array, and it also deletes it from our hash map, right? Deleting from the hash map is important because you don't want to delete, multiple items. Because remember, if current in map pretty much says that only delete this once, because if it goes into the if statement, current's not going to be in map anymore is one way to think about it, right? Because we're deleting pretty much what current is, right? All right. Now, regular stuff, we're going to say I minus equals 1. This ensures that we're going backwards, right, through the array. All right. And for this specific question, we have to return nums. All right. Oh, simple mistake. I accidentally said hash instead of map at line 19. All right. So it looks like we're good to go. Let's see if it submits. There we go. So this is one of the many ways to solve this question in Python. There are other ways to solve it, such as saving all the indexes of the last seen numbers and maybe sorting them so you delete them in the correct order. But this is one of the better ways to do it in O of n time with a O of n space. Hope you guys enjoyed the video.